Hi, everybody. Thank you for joining. We should be beginning shortly. Danny, do you want to start maybe a minute or two?
Yep. Yeah, sure.
Okay. Hi, everybody. Thank you so much for coming. And today we are going to kick off our What is Data Science and Artificial Intelligence workshop. I'm Aditi. I am the co-lead for the logistics team for the Data Science Committee. And also co-leading this workshop is Danny, who is the other co-lead for the logistics team. So thank you so much for coming, and let's jump right in. So let's first talk about the fourth paradigm. So there are four main paradigms: empirical science, theoretical science, computational science, which is the ability to query the world, and also data science, which is the ability to download the world. So we're going to talk a little bit more into data science today. What is data? So data is simply, it can be quantitative, qualitative, categorical, numerical, and more. So some examples of quantitative data includes height, weight, age, etc., basically numbers. And some examples of qualitative data includes descriptions, opinions, and etc. And let's talk about metadata. So metadata is essentially data about data. So it can answer how and etc. about the data that was collected. For example, let's take a digital photograph that was taken from our phone, for example. An example of the metadata itself is the data explaining where the digital photo was taken and when it was taken. And all of these information is super important for data scientists and machine learning experts to analyze these trends. Data. So big data is used by companies like Facebook, Instagram, Google, YouTube, and other several big corporations to generate massive amounts of data called big data. And it allows you to have more confidence in any analyses you conduct. And big data is large and complex data that needs advanced tools to visualize and process it to uncover insights and trends. And for example, we can see with this diagram to the right of my screen here, there's the 5 V's of big data: volume, variety, value, velocity, and veracity. And all of these V's essentially is super important when we analyze this data. Let's talk a little bit about pre-processing and exploratory data analysis. So before conducting any main analysis on a given data set, there are 4 main big tasks that we need to complete in order to make sure that the data that we are working with aligns with our goals and tasks. So the first is cleaning data. So when you're compiling a data set, there may be accidental occurrences of incomplete and or corrupted data. This is extremely important when you're dealing with historical data, for example, as you may have a lot of empty columns or blank cells, and that could definitely stagger and like change your analysis. So you want to make sure that you take care of those empty cells. Additionally, we need to work on filtering your data. In data sets, we can create subgroups that can help break up the data to fully understand the complexity of the data set. Additionally, we need to classify the data. In particularly larger data sets, classifying data that adheres to specific parameters and criterion can help with processing. For example, if you are working with a huge data set, but you really just want to analyze just using a few columns, you can classify that data separately and make sure that it aligns with the parameters you're trying to complete your analysis on. You want to make sure that we remove any bias. So data that's collected may not necessarily be representative of the total population the data is intended to represent. And you don't want that affecting your conclusions and the insights that you take away based off of your data analysis. So it's really important to first understand if and acknowledge if there is a bias and try your best to remove that bias before you conduct any analysis. Furthermore, data sets can be found everywhere. And there are several already pre-existing compiled data sets that anybody can use, and it can be found in several locations such as kaggle.com, data.gov, and toolbox.google.com/dataset search. Additionally, kaggle.com has a lot of data science and machine learning competitions, which you can participate in, and it's a great learning experience. Let's kind of jump into the 3 main components of data science. There's data analytics, machine learning, and traditional software. And I really, really like this triple Venn diagram as it really shows the combination of each subsection and how they all really work together and play with each other. So there are 5 main parts when it comes to data science. The first is obtaining. So we need to gather data from relevant sources. And we can do that such as using kaggle.com or data.org. We also need to scrub our data, which we talked about with the data pre-processing. And we're basically cleaning the data to format in a way that our machine and model understands it. Then we can explore our data. We can analyze and find statistical significant patterns and trends using several statistical methods. Some examples of some statistical methods include k-nearest neighbors and cluster analysis. Then we can work on modeling our data. So we can construct models to predict and forecast, such as using linear or logistic regression. And finally, we need to data. And so we can put the results into good use and apply our conclusions toward a greater solution. And this is just basically kind of a more elaborate and more detailed process diagram, kind of visualizing the steps of data science. So we have problem framing, then data acquisition, data preparation, model planning, model building, visualization and communication, and deployment maintenance. And as we can see, these steps are very similar to the steps that we previously mentioned. And I found this quote a few years ago, and I thought that this is very, very interesting and very relevant to kind of the mission that STEM Fellowship has. So let me read this quote really quick. It says, I define data scientists as someone who finds solutions to problems by analyzing big or small data using appropriate tools and then tells stories to communicate her findings to relevant stakeholders. And this was written by Murtaza Haider, who is a professor of data science at Ryerson University. And because at the core of every big data challenge that STEM Fellowship has, we're basically utilizing the data and coming up with conclusions to help solve an overarching problem. And through your manuscripts and abstracts, you're able to communicate your findings by telling the story. So just something to keep in mind. Also, data science has a variety of applications, some including the medical field, marketing, sports, social media, and banking and finance. And now I'm going to go into a little bit of some examples of data visualization. So this first one is a bar graph or a histogram, and it's very useful for quantitative data to show distribution between various data points. So this bar graph shows the comparison of children per woman and the percentage of per children per woman between 1960 and 2010. And this simple graph basically shows us that the total fertility rate worldwide has decreased from 1960. The next graph is a line plot. And this visualization is mostly used to show change over time. So the above line plot shows the change in life expectancy in years from 1970 to 2010. And the plot shows the upward trend in life expectancy, meaning that it's increased over time. Next, let's talk about the scatter plot. So this visualization is used to show values in correlation to two different variables. So this shows the correlation between children per woman, which is on the x-axis, and the child mortality rate, which is on the y-axis. And this scatter plot shows a positive correlation between the total fertility rate and the child mortality rate. The dot diagram. And this visualization is used to represent the incidence of a value via the size of the dot. So this dot diagram shows the total fertility rate and child mortality rate through various regions of the world in 1960. And one takeaway from this diagram is that most countries had a total fertility rate above 5. And here are some amazing data science tools that you can use to analyze. For example, Python and R are great languages used for data analysis and data visualization. SQL is a great database. And then also you can use Julia, Codap, MATLAB, and Jupyter Notebooks are, of course, a great platform to run these simulations. And now I will turn it over to my colleague, Danny, for the What is AI portion of this workshop.
Okay. Thank you, Aditi. So, now that we talked about AI, now that we talked about data science, now we're going to be talking about AI. So, what is artificial intelligence? Artificial intelligence is a very broad field within computer science that aims to like create machines capable of like mimicking like human-like intelligence. It usually focuses on systems that can perform tasks that usually require human-like abilities. AI systems are sometimes programmed for specific tasks, but some are programmed for more for like variety of different tasks and can learn to adapt and respond to like new situations. A lot of the main key cognitive functions that AI tries to replicate would be learning, problem solving, perception, and decision making. So there are two different types of AI. You have narrow AI and you have general AI. Narrow AI is often referred to as weak AI, is the most common form of AI we see today. It is designed to perform a certain task or a limited amount of tasks very efficiently. So unlike humans who can adapt and generalize across various different situations, narrow AI is very specialized and can't apply its knowledge to unrelated or new tasks. Some examples of this would be virtual assistants like Siri or Alexa. You also have chatbots, so like the ones you use in customer service or even things like ChatGPT. Another example would also be fraud detection or algorithms, so like the ones you use in banking, which can like identify unusual patterns in transactions, but they're only like designed for that purpose. So in short, narrow AI is very effective in its designated area, but can't understand or think like humans can, and it's very confined to its specific task. General AI, which is also known as strong AI, is more of a theoretical concept and doesn't truly currently exist. So unlike narrow AI, which is very specialized, general AI would have human-like cognitive abilities, meaning it can like perform like an intellectual tasks that a human can. So some key characteristics that general AI will have would be, like we mentioned earlier, reasoning, learning, perception, and good knowledge and understanding of diverse tasks. General AI would also engage in critical thinking, adapting its knowledge and applying it across various different situations, just like humans. And it can even learn from past experiences as well. Achieving general AI is very hard, and despite our current advances in AI, we still haven't truly created such an AI. So one main aspect or subset of AI that we're going to be talking about today would be machine learning. As you can see, there's also quite a lot of other subsets as well, but machine learning, I think, is probably the most important out of all of these. But I can briefly kind of go over a little bit of each different subset. So you have natural language processing, so it'll be like machines trying to like understanding and interpreting human language. So it'll be used for stuff like ChatGPT, chatbots, language translators, and stuff like that. Expert systems, they're usually systems used to like uh solve like different like complex problems. Like it's usually using like something like medical diagnosis or engineering. You will have speech recognition, which will be stuff like Siri or Alexa. So AI systems that can convert spoken language into text. You will have planning, which is more of a vague subset, but it's usually capable of planning actions to achieve specific goals. So it's usually used in logistics or like robots that are autonomous. Um, Robotics, pretty self-explanatory. AI will be used to control robots to perform different tasks. Vision, this involves AI systems that can interpret and understand visual information from the world. So like something like facial recognition or object detection. But we're going to be going a bit more deeper into machine learning. So as I mentioned before, machine learning is a subset of AI, and it focuses on the design of like different algorithms that allow systems to learn and improve without the need for any explicit programming. So rather than following specific instructions, machine learning models are like designed to analyze data, identify patterns within the data, and use that information to make predictions or decisions. Um, One of the key strengths of machine learning is that it gets better over time. So as models are trained and exposed to more data and feedback, they improve their performance and accuracy. Um, as mentioned earlier as well, it can also learn from past experiences, which means that these models will kind of evolve and refine themselves based on their prior like mistakes or successes. There are three main types of machine learning, and each of these types are like different approaches to how these models learn from data. So I'll briefly go over the three. It is a little complex, but we will be having workshops throughout the program that will kind of touch upon these things as well. So in supervised learning, uh, models are usually trained using labeled data. This means that the input data will come with like known answers or outcomes, and the goal would be for the machine to predict the correct label or value based on that data. So it will be usually used in like stuff like classification or regression. And over time, as the model is exposed to more data, the relationship between the input data and the desire, the model learns from and gets a better understanding of the relationship between the input data and the desired output. Secondly, reinforcement learning. So reinforcement learning is about learning through like interaction with the environment. So like the model would make decisions, certain decisions, it would receive feedback in the form of like rewards or like penalties, and it will adjust the strategy based on that feedback. This method is usually used in robots and autonomous systems where the model would kind of improve through trial and error, and over time, it will learn what's good, what's bad, and kind of maximize its rewards over time. Unsupervised learning. In unsupervised learning, there is no labels, there's no known outcomes, and the model would try to find hidden patterns or structures within the data. Um, this is useful for like something like clustering, so grouping data points with similar characteristics, or discovering associations and connections within the data. Um, and yeah. Um, One other aspect of machine learning would be deep learning, which is more of a specialized and advanced form of machine learning, which allows machines to perform human-like tasks very efficiently. So deep learning uses neural networks. These networks are made of connected neurons that learn complex pattern within data. So it's kind of inspired by the human brain and how the brain works. Um, Deep neural networks have many layers. Layers in this case refers to a bunch of like a group of neurons, which help the model learn and detect more complex patterns within the data. The more layers there are, the better the model can capture detailed information. One of the biggest challenges in deep learning is that it needs a lot of data and training for it to work, but it is very useful as deep learning has revolutionized many industries. It has made um, many technologies like self-driving cars, image recognition systems, speech recognition systems, and a lot more. So now that we discussed about AI and data science, we're now going to kind of discuss about how AI relates to data science. So AI and data science are very closely related fields. So while data science is more about analyzing and gaining insights from data, AI kind of adds this layer of intelligence and allowing machines to process and learn from that data. So AI can advance data science in many ways. So like for example, it can automates data processing, so reduce the need for intervention and enables more faster analysis of large data sets. AI models, especially machine learning and deep learning algorithms, can also create accurate and predictive models from data, um, which can help businesses and people who use it make uh, certain decisions about whatever the outcomes may be. Um, and with AI, the efficiency and accuracy of um, data-driven insights would also increase, especially in fields like finance and healthcare, marketing, stuff like that. So a lot of how AI would apply to data science would be through predictive analysis, so where AI helps forecast trends or outcomes based on any historical data. You have natural language processing or NLP, which, like I mentioned before, allows machines to understand, interpret language, um, image and speech recognition. So AI would interpret visual or auditory data. So which is very crucial for stuff like healthcare. So for example, in healthcare, you have medical imaging, which uses AI. You also have recommendation systems, so where AI processes the user's like user data to provide like certain suggestions. So like on YouTube or Instagram and other services like that. So you can see how like these two fields kind of work hand in hand and enhance each other in many ways. So now me and Aditi will open the floor to any questions that you may have. So feel free to say any questions if you have any. Yeah.
Okay, well, if nobody has any other questions, thank you so much for everybody for showing out. And yeah, have a great day. Dana, is there anything you want to
Nope. I think
add?
we're
Okay,
good. All
sounds
right.
good. Thank you, everybody. Bye. Have a good
Thank
one.
you, everyone. Bye.